as we start to learn about our polynomials. Over here they told you if it had a degree of 0, constant, degree of 1, linear. Those are what you worked with basically in Algebra 1. Here's our quadratic, degree of 2. We talked about that a second ago. If you have a degree of 3, that's your cubic, and a degree of 4 is quartic. Okay? And they do have other names that go on up. Now, we say that a polynomial is in standard form when all like terms have been combined and the terms are written in descending order by exponent. What does it mean by descending order? Start with
the
highest exponent to the lowest, your standard form. And we've looked at standard form with our quadratic, right? Now, this up here is a lot of busy work, okay? But this essentially is showing you what it looks like as an actual polynomial. So if we look at this one, they do kind of go through and they distinguish for you what everything is. So this one has a degree of what? 5. So the degree of the polynomial is referring to the what? Exponent. You please be careful with that. When you're talking about the degree of the polynomial, we are talking about the exponent of the leading term. Okay? The 7 is the leading coefficient. We'll look at the properties of the leading coefficient. It tells you some things as well. Each one of these, in this case, how many terms do we have? 3. Okay? And we actually do have a constant on this one. Sometimes we don't. Well, you're going to look at one here in a second that you don't have a constant. But that's okay. It's still a polynomial. All right? So then they walked you through some of the things that if you just look at, well, what do I know about this? If I don't do anything, I don't look at my calculator, and I just look at it. Well, here's the things it tells you. The constant term is the y-intercept of the graph. Does that sound familiar? Was that true with our quadratic? Our c, remember? The c was always the y-intercept. What is the y-intercept in this one? -3. The degree tells the maximum number of x-intercepts of the graph. All right, the degree. What's our degree in this one again? 5. Degree 5. So when you look at this, what are the possible, the maximum number of x-intercepts this one can have? 5, right? 5. You're not graphing or anything, you just know by looking at that. The degree of the polynomial gives you information about the shape of the graph and its ends. I think that might mean the ending behavior, essentially. So the degree of the polynomial, again, is important. In this case, the degree 5 gives you information about the shape and the end behavior. And you'll discover this here in a minute, what that means. Okay? Any questions on that? I give you some good things over here in your math terms, and that's what they're telling you over here. It's what's happening at the extreme ends. Okay? And we approach this by looking at the x-axis. Where is the x approaching? Is the x is approaching negative infinity and the x is approaching positive infinity. Okay, well, we're on the coordinate plane, right? Your x always has a what with it? A y. Okay, so if x is going to negative infinity, then where is y going? Because y is going with him, right? Is y going with him to negative infinity, or is y going to positive infinity? What is it doing? Okay, so when we talk about the end behavior, we have to establish both x and y because they go as a pair, right? They go as a pair. Wherever it is they're headed off to, they're going together. Okay? Now, I want you to understand how these look. I want you to come down here. I don't want you to look at the arrow notation. I expect you to use it and to write it this way. All right, what it says here. As x approaches negative infinity, y is approaching positive infinity. Okay? And this one over here, you would interpret, okay, as x is approaching positive infinity, y is approaching negative infinity. Okay? And what what you do, and if you'll come down here, they talk about again as approaching. Okay? As approaching means increasing continuously, and negative infinity means decreasing continuously. Okay? So they will increase or decrease without bound. All right, so we're going to go back. Okay, we're going to start over here on this side. All right, so as x, hold on. So as x continues to negative infinity, as x approaches negative infinity, okay, as he continues to go this direction, what y values is it going to pull with it? Where's your y values headed? Look at your y-axis. Where is it headed?
Negative.
Headed down, so that would be negative infinity. So as x is going to negative infinity, y is also going to negative infinity. So that is your end behavior to the extreme left. Okay, let's go to the other side. Okay, as my x is approaching positive infinity, so now we're headed this direction. As x heads to positive infinity, what values of y is it taking with it? Positive. So y is going to positive. Okay? This is your end behavior. Extreme far left and extreme far right. Okay? Any questions on that? Okay, what can you tell me about x squared and x to the fourth?
They're the same.
They're,
Same format.
they're the same, right? Do they have the same in behaviors?
Yes.
Yes. So question 15 is asking you which one of those shows the same behavior, the in behaviors the same on left and right. And that would be your x squared and your x to the fourths. Now, let's look at A and E. Look at the end behaviors of A and E, and then look at the end behaviors of B and F. What can you tell me about those end behaviors?
The fours are skinnier.
Yeah, they're skinny. But if you look at this one, if you look at the positive and you look at the negatives, the end behavior here, as x approaches negative infinity, what's y approaching? Positive infinity. And then if we look at the negative, as x is approaching negative infinity, what's y doing? It's also approaching negative infinity. Okay? Now, look at C, D, and G and H. Okay? Your x cubed and your x to the fifth. What do you notice about those? Do they have the same? Do they look the same? Okay. All right. So here's our evens. Okay. And here's our odds. Okay. So you notice you did x to the third. You did x to the fifth. What do you think is going to happen if you do x to the seventh? Is it going to have the same end behavior as x cubed and x to the fifth? Yes. Okay. And you graphed x squared and x to the fourth, and they basically have the same end behavior, right? So if you graphed x to the sixth, you think it would have the same end behavior. So you see those patterns, okay? The evens, and then you have the odds. All of your degrees that have an even exponent will have this exact same end behavior, okay? So at the beginning of this, when I said you will be able to tell what the end behavior is before you even graph it, okay? You're seeing it right now. It's either going to take on this format, or this format. These are the four, okay? If it is positive, if it's an even positive, it takes this format. And if it's an even, so let's do here. So even, this is your even positive, and this is your even negative. And down here, this is your odd positive, and this is your odd negative. So if you have an odd, so we had a cubed here, and it was negative, your end behavior will always look like this, because here's your negative x cubed and here's your negative x to the 5th. They're exactly the same. Okay? If I had a negative x to the 7th, it would look exactly like these, right? And it would have exactly the same end behavior. Okay? So you can find all of your end behaviors just by looking at these two right here, or these four, sorry. These four right here shows you those end behaviors. And this is consistent. Okay? So you have those end behaviors. This one is negative infinity and positive infinity. Over here, they are both positive infinities. Over here, this is negative, both negative infinities, and this is positive negative. And check this one. This one's negative infinity, negative infinity. This one's positive, positive. And then over here, this one is negative, positive. And over here, this one is positive, negative. So make sure you have those four done correctly, because you'll use those to answer your questions on your homework.